Hello and welcome back to another episode of Math with Son. Today we're going to be talking about exponential growth and decay functions and how to graph them. So let's get into it. So there are four graphs in front of you, but really you just have growth where they go up from left to right and decay exponential functions where they go down from left to right, and then the reflection of both. Okay? So what you need to look for in order for it to be a growth function is when you have an equation that is something like this, where it's y equals, doesn't matter what's in front, but it matters what is in parentheses. If that number there is bigger than 1, then it is an exponential growth problem, versus if that number is a fraction, so we could still have a 4 in front. If it was a 1/2, then it would be considered a decay function. It would be curving down from left to right. So bigger than 1 goes up, less than 1, 1/2 goes down. There's a bunch of things that will alter it that we will get into. And what would determine if it is a reflection of a growth or a reflection of a decay is if the number in front changed from 3 to like -3. Then you would take that growth function and just flip it over to get it to the other side. Versus if it was a decay, if we change that 4 to a -4 or even a -5 or a -2, or it doesn't really matter, then it would flip over and be no longer a decay, but a reflection of a decay, and have that right there. Now, there are a few other things that could trip it up. For instance, if you were to take a growth function, if I made this x value negative, it would make it a decay as well, but that is rare. And if you took the decay function and made it a -x, it would move it and flip it to a growth as well. Okay? So I'm going to graph a few, show you how this can move up, down, left, and right, and talk about the asymptotes as well on a few examples. So let's say we have our first problem where it's y equals 2 to the 3x plus 1. Okay? So if we had to graph that, that would have an asymptote at 1. And an asymptote is going to be, in this case, a horizontal line. They can be vertical or horizontal asymptotes, but in these exponential problems, it is a horizontal line at 1. And that is a line, an asymptote is a line where the graph will approach but never be equal to. So that is why I have that dotted line there at 1. It is going to be a growth function because the 3 is bigger than 1. And the 2 would typically be the y-intercept, but that's if we didn't shift the graph up by 1 or the left or right or any direction. So the 2 is kind of the starting value, but then if we shifted it up by 1, it would actually upgrade to 3. So my recommendation is plug in 0 for x in most cases, not all the cases, and see what the y-intercept would be. So if we plug in 0, 2, 3, 0, plus 1 ends up being 2 times 1, because anything to the 0 power is 1. So 2 times 1 is 2, plus 1 makes 3, which makes sense because the y-intercept would have been 2, but then when you add 1, you get 3. So we have a y-intercept at 1, 2, 3, and we are going to graph this curving up from left to right like a growth function. Ta-da! The domain and the range for these, because that is a very important feature. The domain is always going left and right forever. The range is typically asked about whenever you have these problems because the range is going up because it's growing, it's going up. It's more importantly above the asymptote, and the asymptote is at 1, so we're going from 1 to infinity. Notice that I did not put a bracket around the 1 because it will never equal the 1 because it's going up above the asymptote. It is never touching the asymptote or crossing it for that matter. Okay? So that's one problem. Let's do another one. Let's do, let's go to this graph over here. Y equals a -2, 4 to the x, and then we'll still have that plus 1. Okay, so this is almost the same problem, isn't it? The only real difference is that I changed the 3 to a 4, which actually means it's going to curve up a little quicker, but you really won't notice it. And instead of it going with a positive 2, it's going to have a negative 2. Okay? Asymptote is still at 1. Asymptote is still at 1. P-T-O-T-E. So that's still there at 1. And the y-intercept would have been negative 2, but if we add 1 to negative 2, you get negative 1. If you were to plug in 0 to that as well, you would end up with negative 1. And instead of curving up, this would have been a growth function, this light blue line that I'm curving, like it was the previous time. But because it's a negative 2, it's going to reflect over. So my recommendation is either mentally or kind of lightly graph the regular growth function and then flip it over so you get the reflection of that growth. Domain is still all real numbers, so still from negative infinity to positive infinity. The range is from negative infinity up until you hit that asymptote, because it is below the asymptote. That's why it's from negative infinity up until 1. All right? A few more for you, because there's a lot of tiny variances that change, not much, but enough. Let's say we have y equals, let's do a decay function. Let's do 3, 1/2, and we'll do x plus 3. I shouldn't have done a 3, but oh well. Minus 4. Okay? So this is going to be an exponential decay function, so when we do graph this, it's going to have to curve down from left to right. The reason it's decay is because the 1/2. The asymptote is still going to be the number all the way out to the right. So this is the asymptote at negative 4. So you can plot that first. I would do that every time first. 1, 2, 3, 4 down at negative 4. And if you plug in 0 here, it would be really hard to do, because if you plug in 0, you're going to have to do 1/2 to the 3rd power and then minus 4. It's still doable. It's definitely doable. What this is doing is moving the y-intercept. You can think of the y-intercept as quote-unquote the original vertex. So if this was the y-intercept, it's not. If this was the y-intercept and we moved it, the y-intercept would need to move down by 4, and then here you would need to change the sign. It's still change the sign, keep the sign in a way, but it's not going to end up being the vertex. It's the movement. It is the transformation. So it would have been at positive 3. So I'm going to start here at positive 3. 1, 2, 3, dot. If I change the sign, keep the sign, I'm going to need to go to the left by 3, because it would have been negative 3, and then down by 4. So left by 3, down by 4 from my y-intercept. So from here, I'm going to go to the left by 3, 1, 2, 3, down by 4, 1, 2, 3, 4. That is my quote-unquote y-intercept. It is the transformation of the graph. Remember how the original should have curved down from left to right? We're going to curve down from left to right and get our graph. If you wanted to attempt to find that y-intercept, you are more than welcome to. You could do it. It is most likely going to be a decimal. The y-intercepts on a lot of these are going to be decimals. So you could plug in 0. You could do 3, 1/2, 0 plus 3, minus 4, and you could get that decimal. I'm going to do it right now. I got to reach for a calculator, though. If we did that, we get 3 times 1/2, 1 divided by 2, raised to the, it would end up being 3rd power, minus 4 is a decimal. It is negative 3.6. So I was close. I made mine pretty much at negative 3. I should have been a little bit lower to make it negative 3.6. I am not too concerned about that, but realize that your y-intercept in most cases is going to be a decimal. All right, let's do one more. Oh, before I do that, domain and range. Silly me. Domain is still all real numbers. Negative infinity, positive infinity. It's going left and right forever. The range, even though this is considered a decay, even though it's going down from left to right, the range is still above that asymptote. It is above the negative 4. So we are saying from negative 4 to positive infinity. Okay, so the graph might be moving downward, but it is still above that -4 for that asymptote. One more. Uno más. Y equals, let's do -2 1/4 to the negative x. Okay? By the way, sometimes you may see an E here. If you see an E, E is just 2.71. So anytime you see an E, it's just an exponential growth, and then you could change it to decay according to this X. So this is not an E. 1/4 is not 2.71. I just wanted to address that sometimes you could have an E. We might do another bonus example at the end to go over that. So ignore that, pause. This is currently a decay. I hope we would agree. But because there's a negative exponent, that means that we would have to reverse whatever this is. If you have a negative exponent, it flips from a decay to a growth. Okay, so this is now upgrading from decay to growth, which means it is going to curve up from left to right as long as it doesn't have a reflection. And in this case, it does. It does have a reflection because we have the -2 there. So this -2 is the y-intercept because there is no changing or keeping of the sign. So it's flat out the y-intercept at -2. The asymptote, there's nothing off to the right, so the asymptote is going to be 0. Now keep in mind this graph would have curved up from left to right. Now it is going to curve down from left to right. And perhaps this is the easiest one that we had. So again, it would have been a decay. The negative x, anytime you have a negative exponent, it changes from decay to growth or from growth to decay. And then the y-intercept was just -2 because there was no changing or keeping. We had no shifting of this graph. So the domain would be all real numbers again, -infinity to +infinity. The range would be going from -infinity to 0 because it's below the asymptote. Bonus example, bonus graph. Let's do it right here. Let's say you had y equals 3e to the x power. Okay, a lot of times when you're doing exponential growth problems or decay, let's make it a little more difficult, -1. This e is just a number. It is 2.71, so it is currently a growth problem. It would be curving up from left to right, like that. But we have an asymptote at -1, so it would need to shift down and at least have that asymptote at -1. The y-intercept would have been 3, but then we would need to move it down by 1, so the asymptote would have been up here at 3, but if we move it down by 1, we're at 2. E is a number, 2.71, so this is just going to curve up from left to right. And there we go. We have our graph. All right, that's going to do it for this one. Domain, -infinity, +infinity, range is above the -1 to infinity. Until next time, everybody, stay positive, and I will see y'all later. Bye.